Sorry, that's my new recording service. It just always does that countdown before it starts recording. So Monopoly, what do we remember? Like, what are some few things we remember with regards to the characteristics of a monopoly? Anybody?
It is a single firm that controls the market.
Good. Yes. So one producer, solo producer of a product or a service in the market. Very good. What kind of product are they selling?
Um,
Is it something that has close substitutes? Is it something that is homogeneous?
it doesn't have substitutes.
Good. Yes. So, one single producer selling a product that has no substitutes, so their product is completely unique and original. You cannot find it, and they don't really have any competitors, right? Because their product is so unique. Also, if you are a sole producer, what does that mean, right? We saw that in Perfect Competition, right? We had these two types of side by side graph of the market and the farm. We had big Q, we had little q. So what does it mean in the for the monopoly in this situation of big Q and little q? Do those things exist? Do we have two separate quantities? Just a yes or no question, you guys.
Yes, I think.
Okay. Um, the actual answer is that they don't, because, and I'm glad, it's good to make mistakes so that you know where you're making your mistakes, and I can clarify that for you. So with Perfect Competition, we had a big key, which was the quantity that was produced by all the farms, right, in the market. So this is market quantity, and this is farms quantity, individual farms, how much they're making. But in monopoly, if there is only one producer, right, only one farm, that is in the entire market, this queue and this queue, right, they're just there is no difference between them, right? Because whatever this one farm is selling, right, they're servicing the demand, right, that exists for this product in the entire market. So the farm is also the market, right? So the demand that they face, right, which brings us to the demand curve for a monopoly, which is different than Perfect Competition, right? In Perfect Competition, we saw that farms face this kind of perfectly elastic demand curve, right? Whereas with monopoly, the demand that they face is a downward sloping demand curve, right? And for them to sell more, right, if they wanted to increase their quantity, their price would have to drop. And that comes from the law of demand. If you face a downward sloping demand curve, you're gonna have to lower price in order to sell more, which is very different than Perfect Competition, right? Because in Perfect Competition, as long as you accept this price of P star, you can sell as much as you want. You have infinite demand at this price of P star. You can sell as much as you want. You don't really need to lower your price. So it's very different, from Perfect Competition in this sense too. What about barriers, you guys? What do you remember about barriers to entry or exit?
There are barriers because it's like a market where there's only one seller.
Yeah. So big barriers, I mean, like, is it possible or easy for other farms to come into this market?
No,
No. Why not?
because because the difference between this and perfect competition is that in perfect competition, when firms can enter, like if people enter or exit, it's because everyone sells the same thing. Here there is only one firm that has the power and that controls the market price.
Right, but you're correct, right? So, but with barriers to entry, we're talking about, are there significant, like, let's say, obstacles, right? If I want to come in, can I come into this market? So with perfect competition, we saw that there are no barriers to entry, really. Like, there are no legal barriers, there are no economic, like, financial barriers. Like, these things didn't exist with perfect competition. It was very easy to come in and out of that kind of market. But with monopoly, that is not the case. It is very hard to get into a monopoly market, right? Because, of course, one farm has, sometimes, there will be legal barriers, which are patents, copyrights, or, government sometimes gives rights to, service, like with utility companies, like local utility companies, the government, tells one farm or one company, they'll tell them, like, I want you to provide electricity or water service to all of this neighborhood, because it's cheaper for one farm, to provide that at a lower cost than if there were like a few farms doing the same things. So there are, economic barriers, with economies of scale. There are legal barriers with patents and copyrights. And also we saw that, if you have like, if you own the resources to produce something, that is also very difficult, right? It also makes it very difficult for other firms to come in, because you own the resource to make the thing with, right? So De Beers and, Intel, you owning microprocessors, and De Beers, owning most of the diamond mines around the world, right, makes it very difficult for competitors to come in and have that kind of market power. Okay. And then lastly, we talked about how the last difference was that a monopoly, right, is a what? What is a perfect competition, and what is a monopoly? A perfect competition is a price. Perfect competition, they're a price what? There's a phrase.
Price
Takers. Price
Good.
take.
Yes. Perfect competitions, they're price takers. They take price, they accept it, they take whatever market tells them the price is. Monopolies are what? They're price makers. They set the price. They have influence. They can not only choose quantity, but they can also set their price. Okay, that is why producers hate being in perfect competitions. Everybody wants to be a monopoly, because you can set your own price, and other things too. As a society, from a societal point of view, perfect competition is a great thing, because it achieves efficiency and it has other wonderful things. But if you are a producer, if you're a seller, you want to become a monopoly. Okay. Okay, so now let's take it to over here. So we started talking about, we looked at, the demand curve for perfect competition, and then, side by side comparison between perfect competition and monopoly. We saw that the monopoly has a downward sloping demand curve, right? So, as if you lower your price, you will sell more, right? But you're gonna have to, you can only sell more if you lower your price. So that is the whole tenet, right, of the law of demand. So that also has important consequences for the marginal revenue. Okay, so the marginal revenue, hopefully, as you guys remember, in perfect competition, price was equal to marginal revenue, which is also equal to their demand, right? So all of these things were equal in perfect competition. The additional money that you can make from selling one more is always equal to price, because price is constant. Here, as you see, the price is no longer constant. If you want to sell more, right, going from 1 to 2, you're gonna have to lower your price. So hopefully you see that has some important consequences for your marginal revenue. And now let's take a look at what that is with this table. Okay, so here the first two columns, it's just the relationship between price and quantity. So of course, that is just how, like a demand schedule, right? So it's a price and quantity. So at the price of 7, 0 quantity is demanded. At the price of 6, it's 1. So as price is going down, quantity demanded increases. Okay. And then this column is price, total revenue, which is, just price times quantity, just multiplying, at each level, at each output level, right? You're just multiplying price and quantity. Okay, so 7 times 0 is 0, 6 times 1 is 6, 5 times 2 is 10, 4 times 2 is 12, and on and on. And then the last column is marginal revenue. And how do we show that? Like, what's the formula for marginal revenue, or how do we calculate it?
The change in total revenue divided by the change in price, I think.
Price?
In quantity, sorry.
Good, Frida. You're doing great. So yes, exactly. It's a change in total revenue divided by the change in quantity. Always remember that it has to do with quantity, right? And then so what we see here is that we can calculate this marginal revenue for every single at every single output level, right? So for the first unit, right, for the first unit that you're gonna sell, the marginal revenue is this, right? It's 6 minus 0. So the total revenue from the first unit is 6. The total revenue from, if you're not haven't sold anything, that's 0. It's 6 minus 0 divided by the change in quantity, which is 1 minus 0. So that gives you 6. So therefore, that's how we got this marginal revenue numbers, right? For every single quantity, right? We can do the same thing. So what do you notice about these, like, what do you notice about marginal revenue? What are some things you notice?
It always decreases.
Decreases? Yes, so it is decreasing, right? It starts out positive, and then it becomes smaller and smaller. It crosses, it becomes 0, and then it starts becoming negative. Okay? And what you also notice is that, at every level, at every output level, right, if you take a look at the price and then the marginal revenue, they're only equal to each other at that first that first level of output, right? When quantity is 1. Everywhere else, right, if as your price is dropping, goes from 6 to 5, your marginal revenue, right, at that output level, right, if you're selling 2, your price is 5, but your marginal revenue is 4. If price is 4, but your marginal revenue is 2. Okay, so hopefully what you notice from here is that price is no longer equal to marginal revenue as we saw in perfect competition, but it is in fact your price is greater than your marginal revenue, or your marginal revenue is less than your price. Okay, and by how much, there is actually
So wait, so here you want if marginal revenue is lower than
can you say that again, Frida? I couldn't quite hear you.
that then in it's I'm sorry, it's something like no. Okay. I don't understand why marginal revenue is less than price, because if marginal revenue is less than price, then you're not making any money.
No, it's not that you're not making any money. It's that, every time you sell an additional unit, you have to lower your price. Okay, so let's do it with this graph over here. Okay, so I think we did this a little bit last week. So let's see if this is we're gonna show what happens, if you have to sell, right, go from selling 1 unit to 2, right? So for at the price of 6, okay, you sell 1, then the quantity demanded is 1, okay, and at the price of 5, the quantity demanded is 2. So in order to sell 2, right, you had to lower your price by $1. Okay, so then some interesting thing happened when you lower your price. So let's see. So total revenue, right, is related to marginal revenue, right? So marginal revenue is the change in total revenue divided by the change in quantity. Okay, so let's see what total revenue is. Total revenue is price times quantity. Okay, so let's do it for the first. If I sell only one, what is my total revenue? What is that rectangle?
6.
Good. It's 6, which is the height, and then 1, the base, right? It's 6 times 1, which is 6. And what about if I sell 2?
5.
10.
Frida, why is it not 5? Because if you lower your price to 5, how many are you selling?
2.
2, right? So it's 5 times 2. Okay,
Oh,
so it's 5 times 2, which is 10. Okay, so then the change in my total revenue is what? 10 minus 6, right? So if I do change in total revenue divided by the change in quantity, it's 10 minus 6 divided by 2 minus 1, which is 4. And this is also, right, this is my marginal revenue. So it's not that you're not making money, right? But each time you sell, right, you increase your quantity. So when you sold that first unit, right, the total revenue, that the entire the area of the total revenue was all of this, right? Are you with me? So it was so if I sell 1, right, the total revenue would be all of this. Yes. And if I sell 2, my total revenue is this rectangle now. So when I sell 2, right, what happened? I lost this box, right, because I had to lower my price. So I lost some revenue from lowering my price, but I also gained this blue rectangle because I increased my quantity. So my revenue, right, I gained more than I lost. Do you see that? So the change in my total revenue, which is also the marginal revenue. So the marginal revenue was 4, but then the price was 5. Okay. So the price, right? If the 2 units, right, I sold them at the price of 5, but then my marginal revenue was 4. So it's not that you're not making any money, but the additional unit that you sell, right, brings you less money than what you sold it for. Does that make sense?
yes, yes.
Elias, I haven't heard you at all. How are you doing?
Good.
Is this making sense?
Yes,
Okay.
I understand.
Good. Then let's do this. Okay, so the other thing that I want to show you here is that how much like the relationship between, like, say, like the demand curve and the marginal revenue. Okay, so which has to do kind of with the slope, but rather than doing a lot into like formulas, I guess, let me just show you what happens. So when, in this case, right, your price, okay, so going from 6 to 5, so let's do this. Going from 6 to 5, at the price of 6 to price of 5, right, your quantity went from 1 to 2. Okay, and your marginal revenue went from 6 to 4. So your price, right, dropped by $1, but how much did your marginal revenue drop by going from 1 to 2?
6.
4.
no, so like drop by, not like how much did it drop by. So from 6 to 5 it dropped by $1, right? So the difference is 1. And over here, right, it's 2, right? So your price dropped by $1, marginal revenue dropped by 2. Okay, and this is gonna be the case everywhere, so everywhere price is dropping by $1 and your marginal revenue is dropping by 2. Okay, and this is actually universal. Okay, this is if we had, like, if you guys had more calculus, I could show you like this mathematically, like how this works out, that the slope of marginal revenue is going to be twice the demand. Twice of the demand curve. Okay, so by which I mean that when we draw the marginal revenue, and we can draw the marginal revenue as we did the demand curve, we can do the same thing. We can plot this at different quantities, and you will see that the marginal revenue gonna be twice as steep, right? Twice as steep as the demand curve, essentially. Okay, so let me draw this for you guys. Okay, I will do it over here. Oops. Maybe I'll just clear this page. Okay, so let's see. And the price and quantity, and then the demand curve, if I were to just plot it from the table, 4, 5, 6, and then 7. One, 2, 3, 4, 5, 6, 7. Okay, I know that at the price of 7, the quantity demanded is 0. At the price of 0, the quantity demanded is 7. So I just connect these 2 points, and that gives me my demand curve. So okay, so that's my demand for the monopolist. And then I'm gonna draw in my marginal revenue curve. So I'm just gonna use this. You can plot it from this table, and then there is another easier way of doing it. Which is, because I can't really show you, this would be more, you'd be able to understand it a lot better if I could show you the I guess the math. But for now, just trust me when I say this. The marginal revenue, we know that it starts at this quantity of like 6. At the price of 6, it's at 1, and then at the price of 4, it's at 2, and then it's like something over here, and then between 3 and 4, as you can see from the table, right, it goes from 6, 4, 2, and then at the quantity, right, between 3 and 4 quantities, that's when it becomes 0. Okay, so I'm gonna do it over here like this. So this is, I know this is where it's gonna become 0, so I just do it like this, and then I know that from there on it's gonna be a negative number. Okay, so this is your demand curve for the monopolist. This is the marginal revenue, which is, as you see, right, they're only equal to each other at this at this quantity of 1, right? So which is equal to 6 for both of them. So I should show this better. Oops. So it's like this. Okay. So any question on how we got this graph, or how to draw this, Frida?
No.
No? Okay, so the only thing I want you to remember is where the marginal revenue curve intersects the horizontal axis. It's gonna cross the halfway. It's gonna cross the horizontal axis halfway. So you see that we drew in. So we're showing that our quantity goes all the way up till 7, right? And where it's crossing the horizontal axis is between 3 and 4, so it's like at 3.5, which is midway between 0 and 7. So that has to do with the fact that the marginal revenue curve is going to be twice as steep as the demand curve. It is always going to be 2 times as steep. Okay, so this is why when here. Wow. So this is why we saw that when price is dropping by only 1, right, marginal revenue drops by 2, right? So it's double, right? It's twice as steep. So that is what you have to remember, that you're gonna make sure to draw it in such a way that it crosses the horizontal axis like halfway. Okay. Then let's talk about this a little bit. Total revenue and price elasticity. So we saw this when we talked about when we had our discussion on elasticity, right? We saw that along a straight line demand curves, right? We can have many different ranges of elasticity, and mainly there were 3, right? In the top half, right, of the demand curve, it was elastic. In the middle, right, where it's the midpoint, that's where we saw that it was unit elastic. And from the midpoint until you reach the horizontal axis, this is where um, it is inelastic, right? So that has, of course, important implications for total revenue. Hopefully, as you guys remember, if you if the demand for your product tends to be elastic, right, you can raise total revenue by lowering your price. And then if your product, the demand for your product tends to be inelastic, you can raise total revenue by increasing your price. Okay, so it sort of matters, right, whether the demand for your product is elastic or inelastic. So here, this is kind of relevant to the monopoly decision, is because the decision about where to produce, right, is dependent on this graph a little bit. So here, if you this is the straight line, this is the monopolist demand graph, right? So this is the demand, and along here we're showing where this is, the elastic region is, where the unit elastic region is, where the inelastic region is, right? So those are your 3 regions. And then we have the marginal revenue curve over here, which as you see, it's the same graph as before. It's 7, and then at 7, and then it crosses at 3.5. This is the marginal revenue, and then this downward parabola here is the total revenue, right? This is the total revenue graph, and it is maximized. Total revenue reaches the most maximum it can be where the demand is unit elastic, so at this midpoint. Okay, and this also corresponds with where the marginal revenue is 0. So if you had calculus, this is very easy, because the marginal revenue is the first derivative of the total revenue. So we know that total revenue will always be at its maximum when marginal revenue is 0. Okay, so what does all this mean for the monopoly? Okay, so what all this means for the monopoly is that monopoly will only produce, right, they will choose their quantity in the region where it is elastic, where their demand is elastic. Okay, because in the inelastic range, as you see, this is where marginal revenue is zero. All of this is where marginal revenue is positive, and then from here marginal revenue starts becoming negative, which corresponds with the inelastic region of their demand graph, right? So all of this region all the way until the midpoint, right, this is where their demand is elastic, and they will choose a quantity in this elastic region. They will never go and produce somewhere over here, because it means that their marginal revenue would become negative, and nobody wants to lose money by selling more. So that is all there is, that the monopoly will operate in the elastic region of their demand curve, because this is where the marginal revenue is positive. Okay, any question?
No.
All right, great. So now let's take a look at how they find out their profit maximizing quantity. Okay, so let's try this again. So this is price quantity. I have my demand over here. So and then the marginal revenue, you can start it, at all the way at the top, coinciding with the demand. And all that matters is that you intersect it like halfway in your horizontal axis. So marginal revenue, bring it down over here, put it a little bit past the horizontal axis, so that they know that it becomes negative and it doesn't just stop at zero. So then, if you are a firm, right, what is your ultimate goal, right? Your ultimate goal is to maximize your profit. Okay, and profit maximizing, hopefully has to do with choosing a level of quantity where your total revenue minus total cost, like this difference, is maximized. You want to maximize your profit, which means that you want your total revenue to be as big as possible, total cost to be as small as possible, and then you want to maximize this difference. So how do we choose that quantity, right? What is the profit maximizing quantity? So in order to do that, remember, always remember that the profit maximizing quantity, the rule for choosing quantity that will maximize your profit, is the same for all the firms. Okay, they're gonna do that where marginal revenue is equal to marginal cost. Okay, this is the same. This is not different than perfect competition. So then we bring in a marginal revenue curve. Sorry, the marginal cost curve. This is the marginal revenue curve. And at the intersection of marginal revenue and marginal cost, this is the quantity that the monopoly will produce. Now, if this had been perfect competition, we knew that, with perfect competition, it's with perfect competition, it's very easy, right? Demand is equal to marginal revenue, which is also equal to marginal cost. It's equal to price. They're all equal to each other, right? So it's different with perfect competition, because the price is the same as the marginal revenue. But with monopoly, right, once they find the quantity, they're gonna find the price that they're gonna charge for this quantity by taking this quantity and finding where it hits your demand. So I take this QM and I'm gonna extend it all the way until I hit the demand curve. Okay, so then I just go back to the vertical axis to find, and this is the price that they're going to charge to produce QM. So this is the monopolist will produce QM, and they find that by finding the intersection of MR and MC, and then they're going to charge the price by finding where this output level, this QM, hits the demand curve, because this, right, the demand curve, right, it represents your willingness to pay. So this is the highest willingness to pay for this quantity of QM. So they're going to charge the highest price that people are willing to pay for this quantity, which is PM over here. So this is their quantity. I'm sorry, this is their price. And this is their quantity. And then we can also bring in the average total cost curve to show the profit. Okay, so the average total cost, like let's just say it's somewhere up here. So then I know that at the quantity of QM, this is how much my average total cost of producing QM. So this is ATC of QM. So then all of this, right, the difference between P minus ATC times QM, that's my profit. Okay, so profit greater than zero. Positive economic profit.
And so P is marginal revenue.
P is price. So can you just show me with your cursor which one do you mean? Marginal revenue is this one, this line. This P star, so I'm sorry that I changed it a little bit. This P star is the same as this PM. So here I wrote PM to remind you that this is price of monopoly, and that but the P star and the Q star, it's the same idea as this PM and this QM. So here we're seeing here, right, in this graph, what the monopolist's profit maximizing output is, right? And then what is the price that they charge. Does that make sense?
For the pink region, it's profit, right?
Yes.
So then the margin, the average the score that's below average total cost, it's total cost, and from P star to zero, it's marginal revenue.
No, so P star to zero, that would be, right, so this times this, right, this entire box, that would be your total revenue, right? And then your average total cost would only be the bottom, right? Because the average total cost is like right here. And then what you're left with, if you subtract the whole thing, right, minus this bottom box, is this much, which is your profit. Yes?
And how did you get that the whole rectangle from P star to zero? It's revenue.
Because total revenue is price times quantity, right? So my quantity is over here, at Q star. So that's my base. This is my height. So then all of that's my total revenue. And then only this much is my total cost, right? So I subtract the entire box minus the red box. I'm left with the above profit. So what can I help with? I'm not sure if I'm understanding or at least answering you correctly.
No, it's okay.
Okay, so ignore that. I made I didn't put P star and I didn't put Q star, but it's the same idea. This is pre-made graph. I just wanted to show you by drawing it in front of you, like how I got this. Okay. So this is demand, equals to average revenue, which is equal to price. But the main idea here is that the marginal revenue is not the same as their demand or their price. They're two different lines. Okay, which is what makes all the difference, right? That their marginal revenue is equal to marginal cost, but now they can charge a higher price. Okay, so any question here?
No.
Okay. So then, okay, so one last thing. So what do you think? We see that they have positive economic profit. Okay, so remembering back to perfect competition, and how when there were economic profits in the short run for those perfectly competitive farms, but then we saw that those profits didn't exist in the long run. Do you think it's going to be the same case with monopoly? Yes or no?
Can you repeat the question?
You don't understand the question?
Can you repeat it, please?
Yeah, of course. Yeah. So what I'm saying here is that, remember, okay, so here we see that this monopoly, they're making positive economic profit, right? So with perfect competition, we saw that farms were making positive economic profits in the short run. Sometimes they had positive economic profits, but then what happened was that more farms came into those markets when they saw other farms were making positive economic profits, and that profit, started to become smaller and smaller and smaller until there was no more economic profit in the long run. So do you think this will happen to the monopoly too? Like, what is your guess?
I think that no.
Okay, that's fine. So that has to do, remember back to why perfectly competitive farms couldn't keep their profits. They couldn't keep their profits, right? These positive economic profits, because there were no barriers to entry, right? Because farms could just come in, if outside people saw that this market was making a lot of profit, because there were no legal barriers, there were no economic barriers, no farm was controlling, all of the resources. None of those barriers existed in perfect competition. It was very easy for people to come in and take away some of those profits. But it is never going to be that case with monopoly, because there are significant barriers to entry. Okay, so it is very likely that they're going to be able to keep this economic profit, not only in the short run but also in the long run. Okay, because there are significant barriers to entry in this market. People just cannot come in anytime they want and get some of those market share that this monopoly has. It's impossible. Okay.
Okay.
So here, monopolies, they're going to be able to keep profits into the long run due to barriers to entry. Okay. Then let's talk a little bit about this idea of efficiency. If you remember, I touched upon this on our very last class when we talked about perfect competition, that there are two kinds of efficiency that perfect competition, the markets, they achieve. One is this idea of allocative efficiency, and the other is the idea of productive efficiency. So allocative efficiency has to do with, producing a level of output where the price is equal to the marginal cost. And we know that, this is what happens in perfect competition, because they produce where marginal revenue is equal to marginal cost and price is equal to MR, right, in perfect competition. So we know that, this is true in perfect competition. They produce where price is equal to marginal cost. And therefore, total welfare, right, for society is the maximum. Remember, total welfare is the sum of consumer surplus and producer surplus. So that area, remember those triangles, they're the most maximum that they can be in perfect competition. Perfect competition achieves that. It's great for society that we can have as much consumer surplus and as much producer surplus as possible with perfect competition, because they're allocatively efficient and they produce where price is equal to marginal cost. Okay, and then productive efficiency is the idea where the market produces at a level, right, a level of output at the lowest possible cost. So we remember how I just said that, with perfect competition, they're gonna produce, right, in the long run there is zero economic profit, right, which means that price becomes equal to the minimum of ATC. So this is the idea of productive efficiency, that you're producing at the minimum of your average total cost. Okay, so all of these things, right, efficiency is achieved by perfect competition. So that's why we keep bringing perfect competition, we keep talking about it, we keep bringing it back again and again, because we want to compare all of these other markets to perfect competition to see how they do. So now that we know what perfect competition does, that they achieve all of these efficiencies, let's see what monopoly does. Okay, so for a monopoly, okay, this is the same graph as before. So this is, we're gonna look at it from the monopoly graph. Okay, so this is their demand curve, right? The marginal revenue curve is located below the demand curve, and it crosses the quantity, the horizontal axis, halfway. So this is their marginal revenue, and then we brought in a marginal cost curve, right, Ignore that, it looks like a straight line, upward sloping straight line. We could have drawn it like this too. It doesn't really matter. So just imagine that, it looks like this. But the idea here is that where marginal revenue is equal to marginal cost, right? This is the quantity that the monopoly is going to produce. And then from this quantity, right, they're going to take it all the way up to their demand curve, right, and find the highest willingness to pay for this quantity. And this is the price that they're going to charge. So the monopoly's price is PM and their quantity is QM. And now if you remember what perfect competition looked like, they had, D is equal to MR, right, which is also equal to P. So they're where the intersection of marginal cost and marginal revenue happens is over here, right? So this is how much perfectly competitive farms is going to produce. So QC is the quantity that perfect competition will produce. So this is how much perfectly competitive farms will produce, and the price that they're going to charge is right here, right, where it's the same level. So this is the output they're going to produce, and this is the price that they're going to charge. Okay.
I have to go.
Okay, yeah, we will see you on Thursday.
Okay.
Thank you, Frida. Bye. So just this idea that, if you look at QM and QC, hopefully you notice that QM is less than QC and PM is greater than PC. So monopolists, they charge a higher price than perfect competition, and they produce a lower quantity than perfect competition, right? And by moving away from this perfectly competitive price quantity at QC and perfectly competitive price at PC, what they're doing is they're essentially creating this triangle, which is, once again, from the welfare analysis, this idea of deadweight loss. This is money or whatever, like welfare, that is not going to anybody. It's gonna be lost. Neither the consumers nor the producers are getting a part of this, and all of this happens because they're not producing at this quantity QC and charging this price PC, right? They moved away from this quantity, and therefore you're gonna be left with this deadweight loss, this triangle that is just lost to society. So monopolists create deadweight loss, but of course with perfect competition you have no deadweight loss. Okay, so monopoly, deadweight loss, perfect competition, no deadweight loss. Welfare is maximum. So with perfect competition, consumer surplus would be all of this triangle, producer surplus would be all of this, but with monopoly you're just losing out on this triangle. Okay, any question? Joseph or Elias, you guys have any questions?
No.
Okay. All right, then I will see you guys on Thursday. Thank you so much.
Okay, bye. Thank you.
Thank you.